Okay, our next problem here is an example of how we're going to use our position, acceleration, and velocity functions to solve problems in AP Calculus. So, in this problem here, we have a position function at a football game, and everything being measured here in yards and hours. The first thing they're asking is, what is the position at kickoff when time equals 0? Okay, so what I should be looking at? What function? I should be looking at the position function, which is what was given us. So we want to look at the position at time equals 0. So what that means is I'm literally just going to plug in 0 into this equation. So 0 squared is 0, minus 3 times 0 is still 0, 0 cubed is still 0, minus 1. So my answer is -1 yards, because my unit there is yards. The next part says find the velocity function. So velocity, while we're in respect to t, is equal to just the derivative of our original position function. And to do this, I'm going to have to do a chain rule. So, derivative of the outside with respect to the inside, my exponent's now 2, times derivative of the inside, which is 2t minus 3. This is multiple choice question. I would say try to simplify it, but in this case, I'm going to leave it just as it is because, well, it's a correct function. There's no need to try to simplify and possibly mess it up. Number 3, or part C, I should say. At what moment was Dotson not moving? When was his velocity equal to 0? Well, again, we're looking at velocity, so I should be doing something with the velocity function. I want to know when the velocity function equals 0. That means when I'm not moving. So, I should be looking at this velocity function, which again, we'll write it down from part B. 3 times t squared minus 3t, all that squared, times 2t minus 3. So, if that whole thing equals 0, that means that each and every factor must equal 0. Well, first off, can 3 ever equal 0? No, so I won't even worry about that part. I do have these other two parts, so I'm going to have to say that 0 equals t squared minus 3t, that whole thing squared, and that 0 must also equal 2t minus 3. Starting with this one, to get t by itself, let's first take a square root. Well, the square root of that is still just 0, so 0 equals 2t minus, or t squared minus 3t. I should also then say, well, I can factor out a t here. T times t minus 3 equals 0. And again, if two factors equal 0, that means each one equals 0. So 0 equals t equals t minus 3, and that means that t here would equal positive 3. So I already have one answer, t equals 0, another one here that t equals 3, and then to solve this one, add 3 to both sides, 3 equals 2t, and then 3 halves then would equal this t. So I have 3 different times when Dotson here was not moving. As we move on to the next part, part D. First, it says what was Dotson's position when he was not moving. So I should start again. I want to look at position, so I should be looking at a position function. And at what times? When I was not moving, it says. Well, we just found here in part C, the times were at 0, 3, and 3 halves. So I should be looking at f of 0, f of 3, and f of 3 halves. And all I have to do is plug in 0 to each of those, or plug in these numbers into my original position function. Well, we already found f of 0, which happens to be -1. Again, -1 yards. If I plug in f of 3, I also get -1 yards. And when I plug in positive 3 halves here, I'm going to get an answer of -12.4 yards. And all this you could do longhand or by plugging into a calculator if you are given access to it for a problem like this. Part E, at what time did he become a traitor and cross from the Union to the Nishannic side? In other words, when did the position change from negative to positive? So again, we're looking at position, so we should be looking something with the position function. If I have something changing from negative to positive, that means it has to be going to 0. That's the only way it can cross from one side to another. So I need to set my original position function equal to 0. So let's do that and try to solve. I'm going to first bring 1 to the other side. So I'll have 1 equals 2t minus 3t cubed. I'll take the cubed root of both sides. Well, the cubed root of 1 is still 1. So t squared minus 3t now equals 1. I have a quadratic, so what that means is I need to bring everything onto the same side of the equal sign. So 0 will equal t squared minus 3t minus 1. Okay, I'm going to first here try to factor. What are factors of 1 that subtracts to give you 3? Well, there are none. So what do? I can't factor it. That means I have to use the good old quadratic formula. So t equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a, all over 2 times 1. So when I simplify this, I'll have 3 plus or minus. This guy becomes 9, this becomes negative 4, so 3 minus negative 4 becomes a positive 13. And on the bottom I should get 2. I could leave it like that. If I do it in a calculator, I would get 2 different answers here because it's plus or minus. I should get 3.303 seconds, and I should also get negative 0.303 seconds. Now, something to pay attention to though, one of these answers actually is not correct. And that's because it gave us in the original that time had to be positive. We're not going back in time, so that's actually an extraneous solution. So our only answer here is 3.303 seconds. Okay, one last problem to do. What was Dachshund's acceleration at time equals 1? Well, acceleration is the derivative of velocity. So our velocity function from earlier looked like this. At this point, to try to make it a little easier, I will try to simplify it, knowing I have to take another derivative. So I did this here to get t squared minus 3t, that whole thing squared, times 16 minus 9. So, to find acceleration, acceleration is equal to the derivative of velocity. To do this derivative, I have a big multiplication problem here, so I'm going to do the product rule. So, first, 1 times d2, derivative of the second is just 6, plus 2 times d1. To do the derivative of the first, I'll need to do chain rule. So, derivative of the outside with respect to the inside, times derivative of the inside, which is 2t minus 3. At this point, if it was a multiple choice problem, I would definitely need to try to simplify this a bit. But all we want to know is what the acceleration is at a specific time. So all I'm going to do is take that time and plug it in everywhere for t. So I'm going to plug in 1 squared here minus 3 times 1. That whole thing is going to be squared. This is still times 6. 6 times 1 minus 9. This is still 2. I have 1 squared minus 3 times 1. And I have 2 times 1 minus 3. So what do all these then simplify to? We should have here 3 times 1 is 3. 1 minus 3 is negative 2. Negative 2 squared is 4. So I have 4 times 6 here. I'm going to have 6 minus 9 is negative 3 times 2. This guy here becomes 1 minus 3 again, which is negative 2. And this guy 2 minus 3 is negative 1. So these are my numbers here. I have 24. I should be putting equal signs here. And then this guy here, negative 3 times 2 is negative 6. Negative 3 times positive 2, I should say, is negative 6. Times negative 2 is positive 12. And then times negative 1 gives me a negative 12. So 24 plus negative 12, which adds up to give you 12, and its acceleration, so we should be in yards per, yards per hour squared. So there you have an example problem of how to work through a set of acceleration, velocity, and displacement equations.